The Voyager mission is one of the most extraordinary and long-lasting accomplishments in space exploration. Originally planned as a short mission to explore the outer planets of our solar system, Voyager has far surpassed its initial goals, evolving into a journey that has delivered unprecedented knowledge about the cosmos. This unexpected mission, now ongoing for over 4 decades, continues to relay valuable data back to Earth, hinting at discoveries that could challenge our current understanding of physics. Recently, Voyager 1, the most distant human-made object, resumed sending usable information after months of erratic transmissions. Join us as we explore Voyager's remarkable journey and its startling findings after 46 years in space. The Voyager story began in the early 1970s when NASA recognized a rare celestial alignment, allowing a spacecraft to visit all 4 gas giants, Jupiter, Saturn, Uranus, and Neptune, in a single mission. This alignment, occurring once every 176 years, enabled the spacecraft to use each planet's gravity to propel itself to the next, reducing the time and energy needed to explore these distant worlds. NASA's Jet Propulsion Laboratory, JPL, designed 2 spacecraft, Voyager 1 and Voyager 2, to take advantage of this unique opportunity. Both spacecraft were equipped with scientific instruments to study the atmospheres, moons, and magnetic fields of the outer planets. Launched weeks apart, Voyager 2 on August 20, 1977, and Voyager 1 on September 5, 1977. These twin spacecraft embarked on carefully plotted courses. Voyager 1, the faster of the 2, was directed toward Jupiter and, in March 1979, made its closest approach, capturing breathtaking images of the planet's dynamic atmosphere, the Great Red Spot, and its moons, including the volcanic Io and the icy Europa. These observations transformed our understanding of these celestial bodies, revealing active volcanoes on Io and the potential for a subsurface ocean on Europa. After its success at Jupiter, Voyager 1 moved on to Saturn, arriving in November 1980. It delivered the first detailed images of Saturn's complex ring system and discovered Titan's dense nitrogen and methane-rich atmosphere, sparking interest in its resemblance to early Earth's chemistry. Voyager 1's path past Titan sent it out of the plane of the solar system, ending its planetary encounters but marking the start of its journey into interstellar space. Voyager 2, following its twin's path, reached Jupiter in July 1979 and Saturn in August 1981. Unlike Voyager 1, Voyager 2 continued to Uranus and Neptune, making it the first spacecraft to fly by these distant planets. In January 1986, it provided the first close-up images of Uranus and its moons, discovering 10 new moons and observing the planet's unusual sideways rotation. In August 1989, Voyager 2 arrived at Neptune, capturing stunning images of its deep blue atmosphere, supersonic winds, and storm systems like the Great Dark Spot. The spacecraft also flew by Triton, Neptune's largest moon, revealing geysers of nitrogen gas and signs of cryovolcanism. After their planetary missions, both Voyagers were redirected toward interstellar space. In 1990, NASA declared the start of the Voyager interstellar mission, focusing on exploring the outer boundaries of the Sun's influence. Despite their age and the immense distances, both spacecraft continued to transmit data from the farthest reaches of the solar system. One of Voyager's most iconic moments occurred on February 14, 1990, when Voyager 1, at Carl Sagan's request, turned its camera back toward Earth, taking the famous pale blue dot photograph from 3.7 billion miles away. This image, a tiny speck in the vastness of space, has since become a powerful symbol of Earth's fragility and humanity's responsibility to protect our planet. On August 25, 2012, Voyager 1 became the first human-made object to enter interstellar space, crossing the heliopause where the Sun's solar wind meets the interstellar medium. Voyager 2 followed on November 5, 2018. The data returned by both spacecraft have provided invaluable insights into the interstellar medium's density, temperature, and magnetic fields, challenging existing models of the solar system's boundaries. In interstellar space, the Voyagers have made groundbreaking discoveries, including the detection of a new type of plasma denser and cooler than the solar wind-dominated plasma within the heliosphere. These findings have deepened our understanding of the processes shaping stars and planetary systems. Voyager has also recorded an increase in cosmic rays, indicating that the heliosphere acts as a protective shield against these high-energy particles. The spacecraft's data on magnetic fields in interstellar space has led scientists to rethink how these fields interact with cosmic rays and other particles. Speculation persists that Voyager could encounter even more extraordinary phenomena, including dark matter or dark energy, which remain mysterious but are believed to make up most of the universe's mass and energy. While direct evidence is lacking, such interactions could subtly influence the spacecraft's trajectory, providing new clues in the study of these unknown forces. There is also a remote possibility that Voyager could encounter evidence of extraterrestrial technology, raising fascinating questions about life beyond Earth. Though the chances are slim, any such discovery would profoundly reshape our understanding of the universe and humanity's place within it. NASA has worked diligently to keep the aging Voyager spacecraft operational for over 4 decades. Thanks to innovative engineering, careful power management, and mission oversight, the spacecraft have continued their journeys long after their initial 5-year mission. The spacecraft are powered by radioisotope thermoelectric RTGs, which convert the heat from the decay of plutonium-238 into electricity. However, as the plutonium decays, the power output slowly decreases. NASA has strategically shut down non-essential systems to conserve energy, ensuring critical instruments remain active. Communication with the Voyager spacecraft, now billions of miles from Earth, is another challenge. NASA uses the Deep Space Network, DSN, a global system of radio antennas, to maintain contact with the spacecraft. As the distance increases, the signals weaken, but NASA has improved the DSN's capabilities, enabling continued transmission of valuable data. Navigation and orientation of the spacecraft require precise control of gyroscopes and thrusters, which are used sparingly to conserve power. The scientific instruments still in use, such as the Plasma Science Experiment and Cosmic Ray Subsystem, continue to provide groundbreaking data about interstellar space. Despite the diminishing power, the Voyagers remain operational, but by the mid-2020s, they may no longer be able to power their instruments, marking the end of the mission. Even after the spacecraft cease to function, their legacy will endure. The data they have gathered has revolutionized our understanding of the cosmos and exemplifies the triumph of human curiosity and ingenuity. Both Voyagers also carry the golden record, a message for any extraterrestrial life they might encounter, ensuring that their story and humanities will continue for billions of years as they travel through the cosmos. The Voyager mission is undoubtedly one of the most extraordinary and lasting accomplishments in space exploration history. What began as a modest plan to study the outer planets of our solar system has evolved into a monumental journey providing humanity with unprecedented knowledge about the cosmos. Originally designed for a short mission, Voyager has exceeded expectations, delivering groundbreaking discoveries for over 4 decades and still transmitting valuable information to Earth. These continuous transmissions now hint at new findings that could challenge our existing knowledge of physics. Recently, after a period of transmitting unclear signals, Voyager 1, the most distant human-made object, began sending coherent data back to Earth. This astonishing feat underscores the mission's ongoing relevance and the tantalizing possibility of new discoveries. The Voyager journey began in the early 1970s when NASA recognized a rare planetary alignment that would allow a spacecraft to explore all 4 gas giants, Jupiter, Saturn, Uranus, and Neptune, in one mission, occurring only once every 176 years. This alignment enabled the spacecraft to use each planet's gravitational pull to slingshot toward the next, saving time and energy. NASA's Jet Propulsion Laboratory, JPL, developed 2 spacecraft, Voyager 1 and Voyager 2, to capitalize on this opportunity. These probes, launched just weeks apart in August and September 1977, were equipped with scientific instruments to study the planet atmospheres, moons, and magnetic fields. Voyager 1, the faster of the 2, first flew by Jupiter in March 1979, capturing stunning images of the planet's atmosphere and moons, including the volcanically active Io and the ice-covered Europa. Its discoveries, such as the presence of active volcanoes on Io and the possibility of a subsurface ocean on Europa, transformed our understanding of these celestial bodies. Afterward, Voyager 1 traveled to Saturn, providing humanity with the first detailed images of its intricate ring system and discovering Titan's dense nitrogen and methane-rich atmosphere. This encounter with Titan altered Voyager 1's trajectory, sending it out of the solar system and marking the start of its interstellar journey. Meanwhile, Voyager 2 continued to Uranus and Neptune, revealing new moons, rings, and unprecedented atmospheric details of both planets. Its flybys of these distant giants, particularly Neptune's deep blue atmosphere and Triton's cryovolcanic surface, provided invaluable data that revolutionized planetary science. Following their planetary missions, both spacecraft embarked on the Voyager interstellar mission, focusing on the outermost edges of the Sun's influence and beyond. The most iconic moment of this new phase came in 1990, when Voyager 1 turned its camera towards Earth to capture the famous pale blue image from 3.7 billion miles away, a humbling reminder of humanity's smallness in the vast cosmos. In August 2012, Voyager 1 made history again by crossing the heliopause and entering interstellar space, becoming the first human-made object to do so. Voyager 2 followed in November 2018. Their data from this new frontier, such as the density of plasma in interstellar space and the behavior of cosmic rays, has redefined our understanding of the solar system's boundaries and its interactions with the galaxy. One of the key scientific revelations of the Voyager mission is the detection of cooler, denser plasma beyond the heliosphere. This discovery, enabled by Voyager 1's plasma wave subsystem, provided vital clues about the nature of interstellar space, previously thought to be nearly empty. Instead, this region contains matter from ancient supernovae and cosmic rays that contribute to the galaxy's composition. Voyager also uncovered valuable information about cosmic rays, observing a sharp increase in intensity after crossing the heliopause. These findings suggest that the heliosphere serves as a protective shield for the inner solar system, guarding it against harmful radiation from deep space. The data is essential for future human space exploration, as it sheds light on the risks astronauts might face beyond the solar system. Additionally, Voyager has offered insights into interstellar magnetic fields, which are far weaker and more chaotic than those within the heliosphere. These observations have prompted scientists to reconsider their models of how magnetic fields interact with cosmic rays and influence their movement through space. While the known discoveries are fascinating, some scientists speculate that Voyager may encounter more exotic phenomena as it travels deeper into space. There is ongoing interest in whether Voyager could detect signs of dark matter, dark energy, or even more exotic forms of matter that defy known physical laws. Although such discoveries remain hypothetical, they ignite the imagination about the unknown forces that could affect Voyager's journey. The possibility that Voyager could encounter evidence of extraterrestrial technology, though speculative, continues to intrigue scientists and the public alike. Given the vast distances involved, the chances are slim, yet the idea of encountering an alien civilization's signal or artifact remains captivating. If the spacecraft were to stumble upon something unexpected, perhaps an anomaly in its trajectory or unexplained interference with its signals, it could spark groundbreaking discoveries about the nature of intelligence in the universe. Even the golden records carried by the Voyagers, containing information about Earth and humanity, serve as an optimistic gesture toward interstellar communication. NASA has managed to keep the Voyager spacecraft operational for more than 40 years through remarkable engineering feats, including innovative power management techniques and precise mission oversight. These spacecraft, originally intended to last only 5 years, continue to function far beyond their expected lifespans. A significant factor in their longevity is their power source, radioisotope thermoelectric generators, RTGs, which convert the heat from the radioactive decay of plutonium-238 into electricity. However, as the plutonium decays, the power output gradually diminishes. NASA has adapted to this by selectively shutting down non-essential systems to conserve energy. The Voyager mission not only advanced our understanding of the solar system, but also sparked public interest in space exploration. The breathtaking images and groundbreaking findings captured the imagination of millions, leading to a renewed sense of wonder about the universe. Educational programs and documentaries have emerged, highlighting the mission's achievements and inspiring future generations to pursue careers in science and engineering. In addition to scientific advancements, the mission has fostered international collaboration in space research. Many countries have utilized Voyager data to enhance their own scientific endeavors, contributing to a global understanding of planetary systems. Researchers have analyzed the Voyager findings to study the solar wind's interaction with interstellar matter, providing insights into the broader dynamics of our galaxy. As Voyager continues its journey, scientists remain eager to analyze the data it sends back. Each transmission holds the potential for new discoveries about cosmic phenomena. Researchers are particularly interested in studying the heliopause, the boundary marking the end of the sun's influence, which offers a unique laboratory for understanding astrophysical processes.